morning, and welcome to the final keynote address of the 38th edition of MOPCA's Common Ground Country Fair. It's a little bit rainy today and was kind of iffy as to where we were going to present this address, but we decided to go ahead and do it on the Common because it's not raining right now, and though it may be raining 5 minutes from now, we're all set. We have our rain gear on and our umbrellas, and I think we'll be ready to indulge in a little bit of thinking about the organic world. So I hope you have had a wonderful day so far at the fair, and I hope it continues all day, and we're certainly all hoping that the skies will clear just a little bit before we get too far along. My name is Ted Quade. I'm the Executive Director at MOPCA. And before we hear from our keynote speaker, I want to take just a moment to say thank you to the hundreds, and I do mean hundreds, of volunteers who have helped make the fair such a great experience this year. Without the many hands of folks who have pitched in to create booths and plan programs and cook food and park cars and string lights and make compost and even move refuse, well, we just simply have to have those helping hands to make the fair, the Common Ground Fair, the Country Fair on our common ground work. So we say thank you to our dedicated volunteers. You are all very much appreciated. And I have to make a little pitch here. For those of you who might be interested in volunteering today, I want to let you know that we have a 4-hour volunteer shift you can sign up for. You'll earn a t-shirt, a meal ticket, and a chance to win a great gift in our volunteer rallies, which will take place at 3 p.m. and 7 p.m. tonight. So if you are really interested in getting involved as a volunteer, go ahead and find our volunteer booths and sign up and get yourself into that raffle. So now I want to introduce to you a very special, outspoken, and dynamic advocate for organic agriculture. He's an Australian who hails from Daintree, Queensland. He's an organic farmer who grows tropical fruit and has 36 years of experience in the diverse world of organic farming. That means our speaker understands the challenges of pest control and weed management in an organic system, and he's experienced with the frustrations and the benefits that come with harvesting, transporting, and marketing organic products. And he's engaged at the policy level as the chair of the Organic Federation of Australia. And as it turns out, our speaker is also the current president of the International Federation of Organic Agricultural Movements. So you may guess, and rightly so, that Andre Loy is a busy guy. But growing organic crops and heading these important organic advocacy organizations aren't the only activities on Andre's mind. Mr. Loy is also a writer, and he's written a book called The Myths of Safe Pesticides. Today, Andre Loy is here to tell us about his experiences as an organic farmer and to talk a bit about the failures of our current pesticide regulation regime. Andre will speak, and we'll have questions and answers following his talk. So here's Andre Loy.
Thanks for that. Firstly, I want to say I'm so pleased to be here. I've heard about this event for years and years and years, and I've always wanted to come here. And you know, for me as an organic farmer, I just adore what you're doing. It's just so good to see so much produce. And the other thing I'm really excited about is seeing the next generation here. I'm 60 years old, the average age of a farmer, and we're losing farmers all around the world, but I think one of the things that we can celebrate as organic farmers is that we're growing farmers and we're getting the next generation, the youth, women involved, and whereas farmers are disappearing around the world, we know that we're getting over 200,000 new organic farmers every year around the world, and that's growing. So we're part of the revitalisation and the regeneration of agriculture. I was invited here to talk about my book. I've got a little copy here, and we'll have copies here later if people want to get it. I'm happy to sign it for people. But why I wrote this book is that as an organic farmer, I'm always told there's no need to be organic because we use pesticides safely. If we use them as directed, there's no problems. So why do you need organic food? And you always hear, look, the amount of pesticides that are on vegetables are so small, you need a truckload. You have to eat a truckload to be damaged. Or the other one, the classic is Roundup. Roundup is so safe, you know, you can drink it. Actually, Roundup is one of the few chemicals where we have what's called an LD50, the lethal dose for humans. And that's been based on the amount of people who have committed suicide on it. So, you know, it is highly toxic. What, I suppose, why I wanted to write this is to turn around what we're told all the time. Every time we have a campaign to get a pesticide banned, we get told, no, where's your data? Where's your science that it's dangerous? It's up to us as the community, as consumers, as farmers, as NGOs, to try and get these things banned. The companies that make the money off it, you know, they don't have to prove it's safe. We have to prove it's unsafe. And we need to turn that around. So what I've done in this book is outlined 5 myths, large myths about pesticides. Number one is that we are told that all pesticides are scientifically tested, and the regulators use this, and as long as you use them as directed, there's no problems. So let's pull that apart first. And when we look at a pesticide product that we buy, for instance, Roundup, only one ingredient in that product is actually scientifically tested, the active ingredient, for instance, glyphosate. But you have all these different surfactants and other chemicals to make it work well. They are not tested. And what isn't tested is the actual formulation. So, for instance, here in the United States, the EPA has allowed 1,400 formulations, pesticide formulations that you can buy. Not one has been tested as a formulation for chronic diseases like cancer, like damaging the nervous system, endocrine disruption. There's a whole range of long-term effects. Some of them are tested for what they call the LD50, the lethal dose 50%. That's based on when you test animals, if you have a kilo of animals, and the amount that you need to kill half of them. And that time that, you know, they use 2 weeks as the time. So if animals die within those 2 weeks from ingesting it, that gives you your LD50. That's all they test for. But that will not let you know, are you going to get cancer? Are you going to get birth defects? Are you going to get degeneration of the nervous system? Are you going to get diabetes, obesity? There's a whole range of things that we know come from pesticides. And the answer is, there is no testing for what farmers actually buy and use on our food. The other one where there's no testing is that every regulatory agency around the world, when they approve pesticides, they approve multiple pesticides. And when I use the word pesticide, I'm talking about herbicides, insecticides, fungicides, miticides, glosicides. And when approvals are made, they might approve several herbicides, several fungicides, several pesticides, miticides, and other chemicals that can be used. And so in the normal course of producing a product, we will see multiple pesticides on it. So when those products come to the market, we have multiple pesticide residues. and nothing is tested for the multiple pesticide residues. We know now, when they start looking at, and a few studies that we have done on these multiple residues, that they can be additive or synergistic. In other words, it's, you know, instead of 1 and 1 equaling 2, 1 and 1 can equal 5. In some cases, 1 and 1 can equal 1,000 in extra toxicity. They multiply. So, but the regulatory agencies make an assumption that there is no multiplication effect. So there is no testing. Similarly, with the formulations, because those formulations have multiple toxic chemicals in them, there are the synergistic effects. So where we now have testing of the whole formulation, they're finding it's actually, you know, 100 up to 1,000 times more toxic than what they actually have on the label. So that's two areas where we're told it's safe, but they're not testing. The other one, which is really critical, is for the unborn, the fetus and the grown children. They are developing and they do not have the same protective compounds that adults have. And we know now that amounts up to 1,000, in some cases 1,000,000 times lower, will affect the developing fetus and the young, and particularly their nervous systems. We now have very good data showing that even the most minute exposure of the fetus to organophosphates, neonicotinoids, carbamates, pyrethroids, they're all nerve poisons, while the nervous system is developing, causes structural changes to the nervous system, particularly the brain. And now we actually have good data showing that, you know, the epidemic in ADHD, attention deficit hyperactivity disorder, which, you know, some people say, well, is it real? You know, are doctors overprescribing? Well, now the consensus is it is real, and we know that it's now being caused by children's nervous systems being damaged by these nerve poisons. There's a whole science now called developmental neurotoxicity. And this is one reason why we need to make sure that these are not in the food. We know for a fact now that most of the residues that children get comes from exposure from these chemicals, comes from eating food. The so-called wonderful fresh fruit and vegetables that they're supposed to eat are causing them problems. And so we're seeing other things like autism, and autism spectrum disorder, the whole bipolar, schizophrenia. We're seeing that increase. We're seeing all these different behavioural problems around the world. And the science shows very clearly it's due to the smallest amounts. And at this stage they haven't been able to even determine how small the amount should be. We do not have that science. And this is the next thing I want to bring up in this, the whole science of what we call endocrine or hormone disruption. When chemicals they test, they use what we would say now is very outmoded, out-of-date testing. They feed them for a certain amount of time, the animals, and they kill them, then they look at them under a microscope. We actually now have much better ways of testing chemicals, where we can use things like MRI scans so we don't have to kill, we can actually see things in real time. We can use cell lines where we can actually test the toxicity, and now we can actually do things at parts per billion and parts per trillion and determine effects without having to kill these animals. To give everybody an idea of what a part per trillion is, if we had 3 Olympic-sized swimming pools of water here, and I was to put 1 drop in it, that is a part per trillion. And we know now that parts per trillion, 3 or 4 parts per trillion. If the fetus is exposed at particular times when they're developing essential body parts, say the reproductive system, the hormone system, the nervous system, it can alter that development. That's how small the amounts are. And for a long time we had some scientists saying, oh no, this can't be right, because they work on very old toxicology. It's actually a concept 400 years old. They say the dose makes the poison. What they do is they feed the animal and they get the dose down to a certain amount. When they kill it and they look under a microscope and everything looks normal, they call it the level of it's no observable adverse effect level, the Nile. Then they say at that level it's safe. Now if we make it 100 times less, it's safer. And or if you make it 1,000 times less, it's even more safer. But what we know with endocrine disruption is that we can get things at the Nile level that seems to be okay, but when we start going down to these parts per billion and parts per trillion, they start to work as hormones and they become more toxic. It's a science, what they call a non-monotonic dose. In other words, most people think a dose just keeps on getting, as you get less and less, it gets less toxic. But there's hundreds and hundreds of chemicals we know that when they start getting down to these really small levels are more toxic. So the big problem is that every residue level that they have on your food, they've made an assumption by saying, well, we'll reduce the dose by 100 or 1,000, so therefore it's non-toxic, without testing it. But the fact is we know now that at that level it could be more toxic and acts like a hormone. And to explain that to everyone, because a lot of people are really confused, well, how come something is so small, when we have a lot of it we don't get affected, but when it gets so small, how come we are, it's more toxic? Because the way hormones work, on our cells we have hormone receptors, and they're a specific shape. And when a chemical of a different shape goes on, they do not register. It ignores it. But what happens with some chemicals, when we make them down to very small levels, they can actually now fit into that receptor. And the best example I'll give you, or analogy, is the example of a lock and a key. If we have a door with a lock and a key, and I get a key is a special shape, and only that key will open it. But if I try to get a metal bar and stick it in the keyhole, I'm not going to open it. It's too big, it won't register. But what I can do is turn that metal into a fine thin wire and make it into a lockpick. It's a different shape from the key, but I can stick it in and open it. That's what is happening with these chemicals. They when they're in a large amount, they're like the big metal bar, but when they're very small, they're like the lockpick. So you can go in, open that lock. In other words, open that hormone receptor and send a signal. Because they're not the hormone, they're sending a false signal, and that's why we call it hormone disruption or endocrine disruption. As a result, what we are seeing around the world now, particularly many of these hormones work like estrogen, pull the body into thinking it's estrogen. And so, for instance, we're seeing the age of puberty of girls going younger and younger, and that is younger puberty is an increased risk in breast cancer, and what we're seeing around the world is the rise of breast cancer is still increasing. This year's figures from the International Agency for Research for Cancer shows that breast cancer is still an epidemic. Yes, we've got more treatments, but we want to prevent it. We don't want people to have to go through treatment. For men, the prognosis is even worse. If we reach our 80s, we will either die of or die with prostate cancer. What we're seeing around the world is this incredible increase in the rise of cancers of the sexual tissues. So it's not just breast and prostate, we're seeing testicular, endometrial, ovarian, uterine, it's all increasing. And that is because of endocrine disruption. We're seeing declines in fertility, declines in sperm counts. We're seeing as well other damages to the nervous system. For instance, it now looks like childhood obesity. It's not really, yes, they're probably eating more food, they're eating a lot of the food they shouldn't be, but what we're noticing now is that the actual normal insulin or the blood sugar processes aren't working properly. So when they eat food, instead of it turning into glucose and being used as energy, their metabolism turns it straight into body fat. And because it goes into body fat, they no longer have the glucose energy, so they feel hungry, they want to eat more again. It's a spiral. And then that leads to type 2 diabetes, which is also on the increase around the world. And we have good science now showing that endocrine disruption from these chemicals is a reason for it. I'll sort of just end up fairly soon, just close with a few things. So what I'd like to do is make it more discursive and let you ask me questions. The last thing I want to really talk about is this concept that our modern pesticides break down rapidly. They're not like the old ones, which were residual. We don't have to worry about them. That is also completely wrong. Many of the modern chemicals are just as residual as DDT, dieldrin, and the ones that, well, they're banned here, but actually DDT is still widely used in India and Uganda and other places. So they're not fully banned around the world yet. But many of the new chemicals, what happens is when they biodegrade, when they break down, yes, they break down relatively quickly compared to, say, DDT. What they don't mention is when they break down to something that is even more toxic and more residual. So if you look at the organophosphates, they break down to these products called oxons. And oxons, on average, can be 100 to 300 times more toxic. So they're saying to you, yes, they break down quickly, but what they don't say is now they're actually more toxic and more residual. And we're seeing that with a lot of them. Once again, they don't test for these breakdown products. So, what I'm saying very clearly in this book is that the regulatory agencies are making data-free assumptions. They're not testing for these metabolites, these breakdown products. They're making a data-free assumption they're safe when the science shows they're clearly unsafe. By not testing the whole formulated product, just testing one ingredient in it, it's a data-free assumption that it is safe, when the testing we have shows it's unsafe. By only testing one of the things that they allow to be used when we're using multiple pesticides, not testing what the combination does, the cocktail that we have, that's a data-free assumption. And, where we have testing, for instance here in the States, when they test the blood of Americans, you'll find that most Americans have multiple chemicals. The Environmental Working Group did tests of placental cord blood, and they found up to 232 chemicals in placental cord blood. In other words, our children are being born pre-polluted. And for me, the fact that 232 chemicals can be found in placental cord blood shows the complete failure of the regulatory system in protecting our most valuable asset, our next generation. So, what I'd like to say here is that what we need to do is two things. As consumers, avoid this, because it's going to be a long time before they do any science. And as we know, I'm preaching to the converted here, eat organic food. Vote with your feet. Don't eat toxic food. That's where we get most of it. The other one is we need to change it and saying we don't have to prove these things are unsafe. We know they're poisons. That's what you're selling them for. You have to prove unequivocally that they're safe. And that's what they're not doing. And we need to turn that around to them. You know, until you can prove it's safe, then you can use it. Thank you. So, with that, well, I welcome anybody's questions. Please.
The present GMOs that Monsanto is selling us, now they're talking about going a step further, that the weeds, as example, and other
herbicides.
Other herbicides are no longer working, and they want to now start using 2,4-D.
Yeah, they just approved.
Now, I'm a little bit older, and I remember back in the 70s and 80s of the huge uproar about cancer and 2 and 4-D.
Yeah.
So can you talk to that?
Okay, look, I'll repeat the question so people can hear it. You just want to talk about the current generation of herbicide-resistant GMOs. They're mainly Roundup resistant, some of the atrazine. But what's happened is now we've got weed resistant and they're not working effectively. So different companies now have just, and actually it's just this week, I think, or last week, the first ones were approved to use 2,4-D, which is half of Agent Orange. So, you know, so actually they're multi-stacked. What will happen now with some of these ones, that it's not just using Roundup, they'll use 3 herbicides, and one of them will be 2,4-D. So, you know, what does this mean? Well, as the gentleman said, he remembers from the 70s about, you know, the cancer. What we do know, and I do talk about it here, is one of the major breakdown products of 2,4-D when it decays is dioxins. So this is the whole thing to say, oh look, it decays very rapidly. Yes, but it decays into probably one of the most toxic products known on the planet. We don't actually know, we haven't been able to determine how low a safe limit is. And dioxins damage the nervous system. We know they cause cancers. We know they're endocrine disruptors. There's, you know, a whole suite of very bad things about it. So, you know, this whole thing of GMOs, you know, they're going to reduce chemical use is just shown, you know, to be another fallacy that these companies are very good at putting out. Any other questions?
A lot of times they tell you you can just wash your vegetables, and I know I raise sheep, and they say you just pour on the stuff on their back and all the lice go away. Yeah. And people don't realize they're all systemic.
Look, thanks for that. I do raise that again in the book as well. What the lady said is that we're always told that the best thing we can do is just wash the vegetables and it's not a problem. And she gave also the example of this, she raises sheep and you have the systemic porons for ticks and lice and other things. What happens is you put that on the animal, and of course the poison goes all the way through, and when the lice or the tick or the flies bite the animal, they die, but it's perfectly safe for our children. And it's the same with many of the chemicals. Roundup, for instance, is systemic. It goes all the way through. So if Roundup has been used in any field where a crop is growing, that crop will have Roundup inside it. You can't wash it out. Probably some of the worst are some of the main organophosphates like dimethoate that they use for fruit fly, which is used widely in most countries. The way dimethoate works is that the poison can't kill the eggs. You know, when the fruit fly goes in, it lays its eggs, and then the maggots will hatch up to 2 weeks later. So the poison has to be active enough that in 14 days' time or longer, when the eggs hatch, the maggots get in contact with the poison in the fruit, and they die. But it's okay, you can feed it to your children, don't worry, you know, trust us, we're the regulators, you know, we wouldn't lie to you. You know, I always remember when, when I first started keeping ducks and geese, and you like to feed them on bits of old salad greens and things, and reading the book saying, oh look, don't feed them your outer lettuce leaves because of the pesticides, you'll kill them. I thought, oh well, that's all right, we just put them on our children's sandwiches instead, But, you get warned, oh no, don't feed a duck this, but yes, it's safe for our children. But the fact is, and this is one of the biggest another mythology, you cannot wash these poisons off. The systemic, or the other reason is that they use these surfactants. If a farmer is out spraying today, he wants his poison to be able to stick to the crop, and it will. This rain wouldn't wash it off. That's, so when it goes to the shop, you can wash it, but it'll still be there. It'll be on it and in it. Any other questions? Please.
Can you comment?
Can you go a bit closer so I can hear things?
Can you comment on the effect of BT on people who ingest it?
Okay. Actually, a really good one, actually. Yeah. Thanks. I was asked to comment on the effect of BT on people who ingest it. BT, I assume I'm talking to organic farmers and people who know what it is, but just in case there are a few people who don't. It's Bacillus thuringiensis, and it puts out these compounds we call lectins. And the actual bacteria themselves are specific to specific pests. So the ones we use in organic farming, when we spray it out, we can use one that will just get caterpillars, another type will just affect beetles. And the other thing is, because we're using a live bacteria, generally what happens is after a day in the sun, 12 hours, it's gone, and we won't have BT residues on the organic fruit that we send to our customers. However, with GMOs that put the genes in, a few things happen. Firstly, every cell in that plant now puts out this poison. So when you eat it, you're getting these lectins. We also know that the process of putting these genes into the plants actually changes them slightly, so they're actually quite different and more toxic than the naturally occurring lectins that come from the natural bacteria that we use in organic growing. And we now know that there's a whole range of adverse health effects, and there are numerous, and we're getting more and more studies into what it can do in terms of allergies, in terms of affecting your nervous system, in terms of affecting your digestive system. We know now with feeding trials that we can see of animals, we can see inflammation through all their tissues. We can see kidney damage, liver damage. We can see damage to the reproductive systems. So, the BT that we have within genetically modified plants is not the same as the BT that we use in organic growing. And more now we're learning that it is highly toxic, and it not only damages the livestock, causes stillbirths, it causes abortions, it causes, we know it actually, the calving rate or the rates of piglets is much less. And we know that when we change them back to non-GMO foods, all those problems fix themselves up. So what is it doing to us when we eat them? And that's now we're actually starting to get the science to show it is not good and is causing a lot of health problems.
What about the other things that are approved for organic production, like pyrethrin, spinosad?
Okay, right, yeah.
Like that, yeah.
Look, I got to ask, and this is a good one. Okay, what about the other things that are approved for organic production, like pyrethrins and spinosad, for instance? They're probably the two most toxic. I'll start with them, and I'll talk about that because we hear it all the time, organic uses pesticides, so what's the difference between that and conventional? The two most toxic that we use will be natural pyrethrins and spinosad, and broad spectrum. At this stage we know of no insects that are resistant to it, so when we call it the tool of last resort, they're vehicles, it's a bit like the crop. But the difference between those and a synthetic pesticide is that they are not residual. Natural pyrethrins breaks down in 24 hours. Same with spinosad. So if we spray one day, pick it the next and bring it to the market, we are not going to be poisoning our customers. That is the reason why we will allow it. But, you know, I always say, you know, someone that's had 40 years now of being an organic grower, I don't use pyrethrins anymore. A very simple one will kill virtually everything, is just emulsified vegetable oil. What it does, it just covers the breathing pores over the tops of insects, suffocates them. Vegetable oil, you know, we're cooking it, we use it for salad dressing, you know, it's edible. You know, if you've got a little bit of vegetable oil residue in the crop, you know, what's the problem? Another very effective one is soap and water. It does the same thing, it actually just clogs up the breathing pores and just suffocates them, so it's not toxic in the normal sense. And I'm sure most people realise that we generally regard regular exposure to soap and water as a pretty good thing for people, so we shouldn't be too worried about it. Clay and water is another one. There are lots of completely non-toxic ways of doing it, but really, in the end, the best way, and what most of us do, is we design systems where, you know, pesticides are actually the tools of last resort, not the tools of first resort. And the research we've got into organic farms show that where these, you know, biopesticides, the ones that we allow, you know, the use is 90% less than in conventional. And we only allow them because they are non-toxic, or they break down so rapidly that there is absolutely no residue on the produce that is sold. So on that level, you can be assured that organic food is the safest food that you can eat.
How do you accumulate and silence these more residual, more toxic pesticides that a grower might have unknowingly inherited on land?
So how do I accumulate?
These more residual, more toxic things that are, you know, sensitive to the PPT. How do you remove them from your system?
Okay, look.
How do you silence them?
Yeah. Okay. Thanks. Okay. The very good question. Just how do you get rid of the long-term residual pesticides that you might have accumulated in your land? So if you've bought an old farm where a lot of pesticides are being used, or you want to transition to organic, and the good news is, and we actually have good data on this, what breaks down pesticides is biology, microorganisms. They will pull it apart. So put lots of compost on your soil, grow green manures, you know, just build up that organic matter. And as you build up that organic matter, you will test it, and you will see that even things like DDT and dieldrin will just disappear. That's the reason, you know, people say, why do we have a 3-year conversion period? Because it takes about that long to get rid of them. You know, if we're going to be honest with our consumers, they're buying organic because they don't want pesticides. We've got to do the right thing. So, you know, by having 3 years and making sure that supervising people and making sure they're doing the right thing, we can be assured then, at the end of that process, that that produce will not have toxic residues. Sorry?
Could you talk about the myth that conventional agriculture has to feed the world?
Okay, thanks. I got actually asked to talk about the biggest of all myths, that only conventional agriculture can feed the world, and if we don't have pesticides, we'll all starve. So I've got a whole chapter on it in this book, because it's the whole justification why we need pesticides. Without them, you know, you and I, we wouldn't be able to get our Big Mac every day and all the fast food that we want. And, you know, to put it in its perspective, at the moment, the world actually produces 2.5 times the amount of food we need to consume. So, you know, more than half the food that is grown in the world is already wasted. So it's a mythology that we need to grow more food to feed the 800 million people who are undernourished. You know, we can't do it now. And if we go in double production, you know, we still won't be able to do it because the problem is with the distribution system. For instance, you know, it's the free market system. Yes, let's say we could get some new great GMO and double production in Kansas, you know, which is actually would be a mythology, but just say, pretend that could happen. You know, that won't go to a farmer who is starving in Malawi because he can't afford it. You know, the way the market works, there's no profit to be made to send it to you know, the people who are hungry because they don't have the money to buy it. It will go to feed, you know, to feed chickens or factory, you know, cattle or hogs because that's what the market wants. The fact is that the majority of the 800 million people who are hungry on the planet are actually smallholder farmers in the developing world. And what we have very good data with, and our organisation, iPhone, works in 120 countries around the world, is we can work with these traditional farmers and we can more than double their production. We can take them from abject poverty, where people actually die of hunger, through to prosperity. What we can do, you know, for instance, to give you an example of one study done by 2 United Nations organisations, the United Nations Environmental Programme and the United Nations Conference on Trade and Development, UNTAG, and they reviewed 114 organic projects in Africa. It's across 2 million hectares. That's what's that? That's about sorry, it's just about 5 million acres, and 1.9 million organic farmers. And what they found on average, when we taught these farmers good organic techniques, and I'm talking about best practice, I'm just talking good organic techniques on top of their traditional systems, how to compost, better weed management, you know, better use of water, and on average we got a 116% increase in yields. And that took these families that were previously, people went to bed hungry at night, it took them into prosperity. They could build nice houses, they could send their children to school, they could afford medical bills. It just changes their life, reinvigorates the communities. The children now actually start coming back into the communities and working the farms now because they can make a viable living. The other fact I want to make too, and I think this is a really important one when we talk about feeding the world. The agribusiness chain only produces 30% of the world's food. 70% is produced by, I assume most of us here, family farmers. And particularly in the developing world, by people with very small areas of land. They've got 5 acres or less and they live on $400 or less per year. And that's actually 87% of the world's farmers. And you know, in the developing world, they actually produce 80% of the food in their countries. But globally, we produce 70%. With these people, because we can get, in the developing world, we can get 100% increases in yield and greater. You know, that's actually taking 70% of the world's food production and doubling it to 140%. That's something that GMOs can't do. You know, we do that. We feed the world. And we don't need to spend hundreds of billions of dollars developing GMOs. You know, we just need education and training. It's simple. For, you know, how can you say, for the fraction of the cost of developing a couple of GMOs, if we had that money and we could use it for education and training, we could take that 800 million people out of poverty within 2 to 3 years.
Do you have GMOs in Australia?
Okay, do we have GMOs in Australia? And the word is unfortunately yes. We have two. We have GMO cotton and now GMO canola. But the push is on now to basically just open it all up. There's a huge push all around the world, everywhere at the moment, to scale up GMOs. One of the things that iPhone is doing now, we're starting to work with other organisations to actually run a whole global GMO campaign now to counter this.
We're living in an age now where even state governments are backing down from GMO labeling laws under fear of being sued by Monsanto and other big agribusiness. Do you have a message of hope for us?
Yeah, okay. All right. The question was, or the statement, is that we're living in an age where even the state governments are now backing down from GMO labeling because they're frightened about being sued. And, well, I'm sure I don't have to tell you about, you know it all. And look, it is a real issue, their power and the way they are being bully boys to try and force things through. If people speak out, they're going to sue them. They try to, we actually know now they actually blackmail people as well to get them to change sides. And there's a whole range of dirty tricks they do, but there's an old saying, if good people do nothing, evil prevails. And I think in the end, it's us. It's the groundswell. We need to turn things bottom up, not top down. And we need to have the power where it belongs, at our level, community level, and we need to take that power and use it. Use it in our purchasing decisions, use it, in our messages to governments and corporations. But it's about us working together to defeat them, because in the end, we are the majority, and we should have the power to do it and take that power.
Can you speak to the effects of pesticides on pollinators?
Yeah, okay, thanks. I got asked to speak about the effects of pesticides on pollinators because this is one of the big issues at the moment, and particularly with one group, the neonicotinoids, which are a new class of chemicals, and they are particularly being blamed, but honestly, for me and the science I've got, it's across the board. They're not the only ones, and if we just got rid of them, we're not going to get rid of the problems. But it is a huge issue. All around the world now, we're having bee colony collapse, and the scientists can't quite work it out. There's a whole range of issues, but we can look at neonicotinoids as one of them. We can look at other chemicals, the pesticides, as endocrine disruptors, actually disrupting behaviour of the pollinators. We can also see, for instance, what we're seeing with bees is confusion in terms of getting back to their nests. What insects use and how they communicate are through pheromones, which are hormones. All animals, we communicate to a degree through our pheromones and our hormone signals. But I suppose in our case we tend to communicate a lot through verbal messages. But for bees and ants and other insects, it's through these hormones. And because these chemicals are endocrine or hormone disruptors, they're disrupting the whole ability of the insect world to communicate. So that is another issue. But the other one is looking at this whole concept of what we call toxic load. And what we're seeing now is that it's affecting their normal defences or immune system. So another problem they have now is we're seeing the Varroa mite. It's always been there, but now it's really affecting them and causing, colony collapse or you're killing whole colonies. Whereas before, they had a few here and there, but the normal immune system could deal with it. Now it can't. Same with frogs, actually. The same thing. We're actually seeing the collapse of frogs around the world to diseases before that were never a problem, because we know also their immune systems are being damaged by this cocktail of chemicals. But it really is the cocktail. What the regulators and people and scientists will do, they have this reductionist approach, and they'll say we can't find one single cause. Because we can't find one single cause, there is nothing we can do to stop it. The problem is that there is no one single chemical. If you want to talk about one single cause, it's all the chemicals, the cocktail of chemicals, and that's what we need to change. And the way to change that is actually to change agriculture and scale up organic agriculture so we get rid of this cocktail of chemicals. We don't need them.
I wonder what you would say when communities are considering spraying for mosquitoes. The kind of fear people have, I don't know if that relates enough, but I think it's the fear of insects, and then what's going to happen if communities are spraying.
All right, and another very good question about, for instance, the spraying of mosquitoes, because people are frightened of insects, and the issues with that. So, look, it's a difficult one, but there are ways of doing it that are relatively safe. But firstly, I want to say that generally speaking, the spraying of mosquitoes has been, on the whole, been shown to be a failure. And one of the examples that's used around the world now to show how spray programs should not be done is the spread of West Nile virus across the USA. It started in one very small area in New York State, and now you've got it across, because what the spraying does, when you spray, yes, you kill some. There's others that survive, and you disperse them. They go away. So what is the spread of West Nile was largely due to the spraying program, the so-called eradication program. So, in other words, we made it worse. And in most cases, when we look at spray programs, we are making it worse. There are ways of doing them in such a way that you can control it. And we've seen good ones with malaria, with dengue in the tropics, and one is to make sure that you, where the worst, or the, how do you say, for a start, most mosquitoes don't spread diseases. Okay, they're a bit of a nuisance, unpleasant, but there's things that we can do to stop them. For instance, use lavender oil or citronella oil, just natural essential oils. We don't need to use toxic repellents on our body. We can use, netting on our houses, screens. There's lots of non-chemical ways we can do to manage them. In the wider environment, we can do things like making sure we stop their breeding places for those worst species. Most of them tend to actually breed around houses and in containers, and where water is left out. We can, the most successful campaigns are where we actually train the people to clean up these breeding places and stop the problem. Don't come in afterwards and spray, it's too late. Prevent it. So if there's nowhere for them to breed, they don't come. Most of these mosquitoes disease mosquitoes don't travel very far. And so that's the easiest. Then if you have to spray, we can use the naturally occurring microorganisms, like BT again is one, BT israeliensis. It only affects mosquitoes and black flies. So put that out. We don't need to use anything toxic, and that's all it will do, and it won't affect people. So there are ways of doing campaigns without toxic insecticides, and we actually get far more effective results. It's the same with the other one I say like that are the weed eradication campaigns, all the herbicides out there, and they're going out eradicating all these weeds. And I always regard those as the weed enhancement campaigns because they're perpetual. I'd like to actually know where one of these campaigns has actually eradicated a weed anywhere. Every year they're out spraying and they'll spray again next year.
Thanks to Andre. If we can take one more question if there are any more questions. Otherwise, I want to say thank you again to Andre Loy for taking the time to come to us from Queensland, Australia, to talk about pesticides and their negative impacts on us. So thanks again, Andre, and I want to present you with a token of our appreciation. This is the much sought after Common Ground Country Fair t-shirt, and I hope we'll take it away and enjoy wearing it. And Andre, are you going to be down?
Yeah.
He will be down at the bottom of the stage here to sign books or sell books and talk a little bit more with questions. Folks who have additional questions can go down and see Andre at the table down there. I want to remind folks that if you're inspired to become a member of MOFGA, you can go over to the membership booth. If you're not a member, please consider joining at this time. Thank you.